Good afternoon. I'm Guy AlLee. I'm with Info at the Internet of Things group doing security for them. I'm specifically in the Internet, software and security group, and I'm going to share some slides with you, and we'll go through and here to help with Internet of Things security. We arm you with a completely different view of security in the Internet of Things, because in spite of all my experience, we've actually got the exception to the rule where security makes things easier. So with that, let's get started. Secure device onboarding for Internet of Things. And this is a way to get your devices secure from the very first minute they first boot up out in the field, and have them immediately attached to the service that you want to have them deliver data to and start working and be secured in that from the very first boot. So to get you in the mood for things here, little question for you to think about. How long does it take to securely onboard 10,000 Internet of Things light bulbs? And define onboard as being from out of the box to securely streaming data to an Internet of Things platform. And really, we're not talking about the one-off case. You know, anybody can take something in a lab and get it up and running. To operationalize the Internet of Things, you really need to be concerned with how you're going to get things active and producing data immediately out of the box. You know, some people may think that this is a trick question, and it's you know, can't be done at all. That's a trivial answer, but we're really talking about the things we're capable of doing today, securing it, best practices today for the kinds of threats that we're seeing out there, and really, I'll call it the minimum level of security for that. And it turns out from our research, talking to customers, it takes from 20 minutes to 2 hours to do that. And, you know, imagine yourself at the top of this building here trying to put those light bulbs in, on top of a ladder, working with a device that has no operator interface. That becomes a sticky problem. And you probably don't want to be trying to typing in 256 characters in a row with no mistakes while you're doing that. So you take and multiply that through, it's on the order of about 1.5 years. So here's what we're going to cover today. I'm going to give you an overview of what Secure Device Onboard is, just so you understand the context of what we're talking about. And it's really within the imperative that we all have to secure and scale the Internet of Things. And actually finding that if you embed identity in devices, you can actually provide for a secure start from the first boot and actually allow you to scale much faster into the Internet of Things. And that all arrives from a handful of things you have to do to secure the Internet of Things. One fundamental of that is identity, and it's something you can't change. And Intel has a technology called Enhanced Privacy ID that does that in a way that's better than anything else out there today, because it actually uses the privacy preserving properties of that, not private from the sense of personal privacy, but private from the sense of machine to machine, private from every other machine out there on the internet. And the promise is that once you've got identity in this way, you can actually hand it out to the internet and find its owner. And not only do that for just Intel devices into Intel systems, but any device, Intel or non-Intel, into any cloud, Amazon, Azure, what have you. And that's what Intel Secure Device Onboard is all about. And why is this important? Well, I draw your attention to the picture here. This is my favorite new thing on the Internet of Things. That's my granddaughter. She's hooked into about 5 different sensors, all going up through the monitor equipment there, out on a Cat5 cable to the nurse's table, which means she's on the internet. And someone coming in and have consequences that are much beyond what anyone envisioned when they put the system together. That's why we need to secure the Internet of Things, because it's not just about things. It's about people. It's about lives. It's about control system and the security of and reliability of systems of systems. All right, so brief overview of secure device onboarding. Let's start with what we're doing today. We got a device that arrives on site, technician installs it, turns it on, and then spends the next 20 minutes to 2 hours putting keys into it, if at all, to secure it. And then someone's talked the IT guys on the work into actually allowing you to put that device on. And quite frankly, that's the first step right today that is a huge problem. We've got the operating technology guys fighting with the IT guys in terms of this whole tsunami of new parts coming onto their network, and having been burned by the printer that was used as a launch pad for breaking into corporate network, they're very gun shy. If you do all that stuff, and it's frustrating, you end up finally with the devices working, but you've spent a whole bunch of time and at least one, probably two people's time doing that. And if you think about doing 10,000 light bulbs, taking a year and a half to do that is just not going to scale. That's actually going to get in the way of the Internet of Things reaching its promise of, the 20 billion devices in 2020, 50 trillion sensors by 2050. It's a huge barrier. It's actually, we're seeing it slowing down the growth of the Internet of Things, which is just keeping the pie from getting bigger for everybody. And that missing element is security. And we think you need to do it in a way that's private from all the other machines, and use an extension to the PKI that exists already, a technology Intel invented at the beginning of 2000 to actually address this kind of issue. What we propose an alternative devices embed identity in them, just like the picture shows here in the upper right-hand corner, embed identity in the device, put hardware security into the device, and then power it on, have it phone into an onboarding service that redirects it to its managing platform. And that allows anybody to set up that rendezvous for their IoT platform if they can prove that they own the device. And it allows to make sure that the device they're onboarding is actually the real one, because you get the authentication of that identity. It solves a major pain point in securely deploying IoT things, and it gets past all the problems with manual deployment, and in fact gets you to the point where you don't even need to provide credentials to people that may not even be working directly for you. And then uses a hardware-based root of trust that is EPID to provide for a zero-touch device onboarding. You just place it, you power it, provision it, and that is the return on investment for customers, for the ecosystem, and for the growth of the Internet of Things. It really allows you to scale, move your POCs to production, increase the number of use. As one of our customers told us at a major industrial manufacturer, you're going to spend a lot of time planning a scalable rollout devices. But once you've been burned, you really need to think it through. We thought it through. We think this is a superior answer. So that's Intel's zero-touch onboarding. It's really a way that takes seconds. Less than a minute is our target, even down to some pretty small microcontroller units. Provisions dynamically at the customer's platform of choice. It's the device. The owner tells it where it wants it to be managed, and that management service registration links up with the device when it powers on. And then it's secured at the hardware level, designed in, and it's ready for device OEMs. So with that, I'm going to answer a couple of questions that we've gotten here. Let me have a look. All right. So first question is this an IoT-only service? No, this is a dedicated solution for the IoT industry. We decided a couple of years ago that it wasn't enough for Intel to secure the Internet of Things for Intel devices. We really need to be able to have all the devices working with Intel devices be secure as well. I mean, Intel has a distinctive competence at the server level down to the client. And as you move down under that to the sensor level, realize that Intel's not going to be in every one of those devices. But if we do identity across the Internet of Things, if we secure the Internet of Things at every device, up through the gateways into the cloud, then we will have a chance for end-to-end security. And Intel is putting this together and enabling the industry for this. It works on Intel architecture, IA, and non-Intel. Okay, let's go back and move on now. So the imperative, secure and scale the Internet of Things. So we've got a history already of attacks on the Internet, and those have progressively started moving into things over the years. A very big example of that is Stuxnet in 2010. Use the internet to reach out and find all the devices, very specific targeted devices that it wanted to attack, and kind of spammed everybody else to get there. But the ability to actually sit there, monitor what's going on the internet, and figure out what devices are onboarding from what addresses to what services is quite possible today just by monitoring the internet. If you were able to break in, you could easily accomplish that. We've started seeing more sophisticated attack on things happening. In 2014, we had the German security ministry report an attack on a steel mill in Germany that came within very close, within minutes of actually solidifying all the molten steel in a crucible. And there's not enough energy built into crucibles to remelt that if it's full. That would have completely trashed that whole operation. 2015, we saw researchers drive a Jeep into a ditch remotely. In 2015, Christmas, we saw the Black Energy attack on the Ukrainian power grid. Then last fall in 2016, we saw the Mirai botnet attack on Dying, actually using cameras, Internet of Things devices, co-opting them to attack. And then most recently, we saw the WannaCry, where we actually started seeing systems that are attached to the internet in hospitals, diagnostic equipment, MRIs, those kinds of things, being attacked. And so the direct attack on critical infrastructure within the Internet of Things. So that really conclusion that has already been made by the United States National Security Technology Advisory Committee to the president. And that is that with 50 billion devices coming in 2020, we've got a small and closing window to ensure that the Internet of Things is in a way that maximizes security and minimizes risk. We want to talk about how you can do that. And so I'm going to start from the highest level and move down to what we're talking about today that helps you do that. The mantra, if nothing else from today's session, is harden the device, secure the comms, and manage and monitor the security. And the security, secure the comms is stuff that we really already know how to do from the IT world. What we're really adding is these new devices out at the edge, and they need to be hardened. But IT is really a tsunami of devices, as you see on the left, coming down on them in their boats there. So right now, you are here. What are you going to do about it? How are you going to make sure that this happens? Well, here's some help for you. Hardening the device today, as we go through this escalating arms race on cybersecurity, really comes down to 5 things. You need to have a protected boot. You need to have device identification and software identification. And that's where Intel Privacy ID, EPID, fits in. And once you've got that identity in there as part of hardening it, we'll show you what else you can do with that later. You have to have protected storage, and you have to have a trusted execution environment for those things. So today we're going to talk about how you can take advantage of, once you put that in place, that's hardening your device. Once you put it in place, invest in that identity piece. There's a whole bunch of other things you can do with it, and a huge payback just from the problem of getting devices onboarded quickly. Just remember, security is essential to scale IoT deployments. If we don't fix this, no one's going to trust the things, and they'll stop investing in it. In fact, the market analysts have already figured that out, and they're calling out that hardware security is a priority for IoT. And then you're starting to see it show up in specs and actually moving into customer requirements. If nothing else, when you're getting things for yourself, require security in them. They need to be designed in, and they need to be at the hardware level. All right, so imperative to secure and scale the Internet of Things. Go on and look at enhanced privacy ID. That's really one of those 5 things we talked about with respect to hardening the device. This is not a new technology. This is something Intel's been doing since 2008. Really came out of the ashes of the Pentium 3 when we tried to do a processor serial number and got pilloried by privacy advocates for enabling Big Brother. We put it into all our integrated CPUs, moved from the chip into the CPU 2011 for Xeon and Core. And then since 2013, we've been moving it into Atom chips. It will be in all of the Internet of Things group roadmap products from Intel by the end of next year. And we're actually off enabling third parties to do this. So we're actually working with ARM licensees, for instance, to incorporate this in their chip design. There's 2.7 billion of them today. So EPID is really an identity model that's created for the Internet of Things and proven at scale. It's a TCG M2.0 has a mechanism called direct anonymous attestation signing that does EPID key attestation. ISO 20008 also has a standard for that. In fact, Intel has implemented that standard as EPID and then is working with both TCG and ISO to unify the standard between the two groups so that it's clear what you actually have to do to implement DAA attestation with EPID. And then we are using it to do open secure authentication for devices. And we've provided an open source SDK. In fact, we'll be going to our 6th release at the end of this year of that SDK. And then we've provided the IP under RANZ terms. It doesn't even cost you. You have to get a license from it, but there's no cost involved. That was a commitment we made to ISO when we standardized it. So proven, scalable, and tied to the hardware. It allows you to do a hardware identity that can attest to the software running on a trusted execution environment. Now, let's look on the right and see how that's different from traditional PKI. EPID is a group key mechanism. So with PKI, one public key, one private key, and they can do asymmetric crypto, one signing for a message and then the other decrypting it to attest that it's authentic. EPID has one public key and many private keys, 1 million private keys, for instance, in a group. So you can do signing and validate that it's from a valid member of the group, but you don't know which member of the group that's from. That's where the anonymity property comes from that allows you to do things privately. And remember, we're not talking about just personal privacy. We're also machine privacy from other machines. Steve Hoffenberg, Director of Analysis for IoT at DDC Research, says it uniquely combines verifiable hardware secured identity abilities and the flexibility to meet the needs of chip makers, OEMs, channel partners, and users. And they see technology is applicable to IoT use cases and identity scenarios. We're going to talk about one of them next. Let's just talk briefly about the ecosystem and summarize EPID, and then we'll get to another set of questions here. EPID really has 3 parts to it. There's roles. There's 3 roles: an issuer, there's a member role, which is your IoT device that wants to attest, and then there's a verifier role, which is the verifier who wants to make sure that it's talking to a genuine member of the group. We've provided the protocol with EPID attestation. We've provided an SDK that's open source for doing both the member and the verifier actions. And then Intel is an issuer. We provide a CA for EPID keys, and we'll provide EPID keys in bulk to any OEM just to Intel. Like I say, 2.7 billion keys. To see an announcement soon about a huge opportunity outside of Intel where we are providing them 5 million keys. So the ecosystem is starting to grow and starting to grow outside of Intel. And then, of course, Intel has trust services that are on the back end, service can do the certificate path validation and manage and maintain revocation lists. Device requirements, minimal. 144 bytes of non-volatile one-time programmable, protected by a secure boot and a key ladder scheme. And then you have to have a cryptographic quality random number generator. We would recommend that you also think through a rekey strategy, which could be as simple as a second key slot, so you can write another key later on should your key become invalid in that device without having to throw the device away. And then a best known method, BKM, encapsulated the EPID applications within a T execution environment. And if it's the same T, you can reuse that across applications from the same EPID group. BKM is also to take advantage of the EPID group attributes to map to a manufacturer ID and product ID. And that automatically happens when you register a group with Intel and start getting keys to write into devices. And then a couple of things you might want to consider that are performance optimization is actually pre-compute the signature and write that pre-computation into your device and protect it the same way you would a key. And that takes care of about 70 to 90% of the time it takes to do a signature. And in fact, we always keep the results of that, so the second signature is much shorter than the first signature on a device. And then if you want, you can also do hardware acceleration. We've seen people hopefully order of magnitude improvement in the signing time when they use hardware crypto. It's basically elliptical curve encryption, just using a different curve than ECDSH uses. And then just to close on what it is, it's a designed-in foundation for hardware identity. And for IoT device manufacturers who need to secure your IoT offerings, this provides trust. It scales with the IoT, it preserves privacy, and simplifies certificate. Imagine trying to keep a hold in 2050 with 50 trillion devices. Are you really going to try and sort through 50 trillion certificates? You've got a system here where you only have to sort through the groups and be able to operate with all the devices that are within that group. So a huge savings in terms of computability. It's before the first boot, so you don't have to put the device out in the field, risk somebody intercepting the device and putting some malware on it before you can ever secure it. And then it's recommended best practice for before you onboard. And the onboarding actually EPID provides an anonymous channel as part of putting together that signing. It leaves you with a secure channel that only the device and the service it's interacting with will use. And then you're actually able to download whatever credentials or even software updates. And you'll see how that's taken advantage of in secure device onboarding. Just keep in mind, this is an open international standard created by renowned cryptographers. It solves both identity and does it in a private way that protects you from additional vulnerabilities in the Internet of Things. As a customer of ours says, in the first minute, I'm concerned about security, but when you start onboarding devices, you get impatient and don't see the consequences it's too late. This is a method and a way that you can avoid those consequences by putting security in from the very first. All right, let's pause here and take a couple of questions. All right, where can I get EPID keys? So EPID keys are available from Intel today. You just contact Intel at our key generation facility. It's through digital. It's www.digital-cp.com, and just tell them you're interested in an EPID group and keys. And this is the same organization that does HDCP keys. It does all the Blu-ray keys. You're actually getting keys generated off the infrastructure that's supplying all the Blu-ray keys to the industry. So they're done at an extremely low cost. Next question is, where can I get the EPID SDK? Today on github.com/intel-epid-sdk. And then question on how big is the SDK. So for the member on a device, release 6 due out at the end of 2017 is expected to fit in about 25 kilobytes for code, and then another so that's the code space, and the data space is from 4 to 9 kilobytes depending on how much space you need for a revocations list, and that'll give you a reasonably sized. All right, let's move on and talk about the device onboarding service. So device onboarding is really a way that you can take advantage of this, and it's really take the EPID identity, use that as a basis for build off your hardware security so that a device can phone into the Intel onboarding service, get linked up, introduced, rendezvous with the management platform that's ultimately going to, and then have those two automatically establish the trust between themselves independently. So unlike TPM, where you're reliant on a third party, other solutions where you're reliant on a third party that if they're compromised can reveal all the devices and all the services that are linked together, this actually does a rendezvous and then completely forgets about the players in that. The device and the management platform to work out among themselves sufficient proof of trust, establish that trust between themselves directly. So it's really a distributed trust model, and it becomes as easy as place the device, power it, hook it up to the internet, and turn it on to provision it. So let's see how that works. So for a device, you'll take a chip, it gets Intel identity burned into that, and usually a final test at the silicon provider. That's manufactured into a board. Manufacturer, OEM, ODM, provides additional credential for an ownership credential, and this is a digital piece of information that ships independent of the physical device to the owner, the person that ultimately bought it. And that can be used to attest to the service that the service really owns it, because the owner gives that digital credential. Think of it as a car title. You put a VIN on a car, a vehicle identification number. In this case, it's a GUID that's written into the device. It's a cryptographically secure way with usually an RSA or ECDSA key into the device to secure this ownership information. And then that information is sent in what's essentially the title. And that can go through the reseller, through online retailer, and actually be endorsed along the supply chain if that's important, to the point where the device is shipped to the user, is shows up on their dock, and the person who's going to operate that device gets this ownership credential and presents it to the management service, AWS, Azure, whatever service they're going to use to manage their device, as part of the registration, because that service has been enabled with Secure Device Onboard from Intel. And part of the registration of a new device into the service is to intake that ownership credential. At that point, it provides, it interacts with the Intel rendezvous service and says, hey, I'm waiting for GUID number 123. When you find him, send him back to me at this IP address. When the device gets plugged in and powered on, the first thing he does is calls the rendezvous service. GUID 123, where's my management service? The service authentication with the device to make sure it's an authentic device using the EPID attestation. And then if that is correct, it'll say, here's the address, go find your new owner. At this point, the rendezvous service is completely out of the way, and the device directly contacts the service, says, here's my GUID 123, and signs a challenge from the IoT platform so that the platform knows it's the genuine device it's expecting, and then turns around and says, here's the ownership proxy I have for you. Go wind your way through all the things that happen to it in the supply chain, and if each of those have done the signing as they're supposed to, you'll get back to the proxy that was installed in the device back here at the manufacturer. You have accomplished a two-way attestation between the two. And then, like the Ginsu knife, but wait, there's more. As a consequence of that attestation, you've left behind an encrypted channel. Over that encrypted channel, you can now provide all the credentials the device needs to interoperate with the service and on the network that it's plugged into. So you send down all those certificates. You can also send down a software update as needed or to work specifically with this platform device. So as a manufacturer, you only need one software load to go out with the device, and then the platform specific version of it gets downloaded by the platform that is going to use it. And last step, we actually provide some replacement credentials so that you can sell this on after you're done with it if you need to, and use the provision again. And then you're operating directly on the network in the customer's site. So you end up with a superior out-of-box experience, scripted, reproducible process. The time to onboard is basically the time it takes to boot. It's less than a minute in most cases. If you've got a device that's extremely slow, it might take longer, but realize this is something you're only going to do once, and that's easily accommodated just by, if you've got plug-in power, you can leave the power on while it onboards. Or just realize that that's part of the life and budget that into the battery life calculation you have to do. And then, when you get to the end with that secure channel left, download credentials that are appropriate to that level device. A battery powered device, you're probably going to use some pretty simple symmetric crypto and change those keys often. It allows you to segregate duties between the installer. He doesn't have to be trusted with keys anymore. It allows you to overcome this IT-OT tension where IT doesn't let devices onto their network because they're afraid of them. It actually automates all secure and trusted device to software onboarding. The privacy is assured by using EPID in such a way that nobody else and try and do the Stuxnet kind of thing, map all the devices, map all the services, and then save those for a future attack when you want to attack all the specific kind of PLCs like they did with Stuxnet. And then it's really just-in-time provisioning of the owner keys at the time you turn it on, and we're not really relying on secure shared secrets that you have to transmit through some other key. So let's briefly talk about the ecosystem and so ecosystem, you've got three entities here. You've got a device on the left, you've got an onboarding rendezvous service in the middle, and you've got an IoT platform usually up in the cloud. And Intel has provided for all of these entities to help enable this. We provide the SDK, that's an open source SDK for the device. We provide OEM development toolkit, open source, free as well for device manufacturers. Actually available on Intel gateways today, and then or will be by the first of the year. And then we have a secure device onboard rendezvous service that was launched already and available. And then we're off enabling third-party cloud service providers, and I'll talk about who those are in a second. And there we sell a toolkit to them, and really that's where the cost of this is born. These services are going to charge you a fee to onboard automatically, and given that you're spending somebody, one or two people's time for 20 minutes to 2 hours, that's a significant cost savings to have it done automatically. This is really activation. It's taking your onboarding from 11 steps in 20 minutes to 2 hours to one step and in less than a minute have that up and running. It simplifies it for your customer, for your ODM, for your installer, and for your ISV platform, and really makes the whole ecosystem work faster and ends up with something that's more secure. So it's really a win-win. I'm not going to spend a lot of time on use cases today. Just realize that we're already talking to customers, and this is getting larger every day. We already have platform managers that you see here. Wind River Helix will have it's already running on that, and there'll be further updates on that as we go through time. And then in the coming months, expect to see several of these other services show up there as well. Working with ODMs to get their gateways and sensors up, and working with device that go in sensors and gateways at the chip level to make sure that they are enabled for EPID and NIST. All right, so with that, just remember, in fact, this is what we showed at the IoT World, where we onboarded a connected device using the service through Helix Device Cloud. And then actually Helix Device Cloud can actually forward that to other services as well. It really comes down to place it, power it, provision it, and then you're secure from the start. All right, so summary, imperative is to secure and scale the Internet of Things, harden the device, secure the cons, manager, and monitor everything. That's your mantra going forward here. Once you've got hardened devices, you will have immutable identity. That's where security starts. And as I like to say, EPID is the key to IoT. Once you have identity, you can use that to do secure device onboarding. And secure device onboarding is set up to enable all the industry, just Intel. Any device into any cloud. That's the promise we're going for. Place, power, and provision. All right, with that, let's conclude with any further questions. Okay, question here, when can I get SDO? SDO is Onboard. That launched in October 3rd at IoT World Congress in Barcelona, and that was specific to some Intel devices and the Helix Device Cloud, of course. Now, there will be a toolkit that I talked about earlier that's available on the for any IoT device, and that's will be available in early Q1 of 2018 for non-IA devices as well. Apollo Lake is the one we launched with. Bay Trail, we're actually going to go back a generation, make sure the Bay Trail I from Intel also has that. Question here, what does it cost? So there is no cost on IoT devices other than the cost of the keys, and keys are that really comes down to the volume you're going to. And then as you saw before, it's really monetized at the services end of this. We will get a share of the revenue that services in the cloud charge you to onboard devices automatically into those. So this is really set up to move the cost of the services where it's offsetting significantly, creating cost savings against what you normally do at the services end of this. All right, well, I want to thank you for paying attention today. I really appreciate your tuning in. I'm going to leave you with a couple other things here so that we make sure things are secure from the start. So here's references for you, additional resources. This is on page 30 of the presentation that's online here. And then also leave you with some references. If you're curious on platform embedded security, Technology Revealed, it's a book that's a free download from APress, has on chapter 5 talks about EPID 1.1, which is an earlier EPID. We're doing EPID 2.0 today, but it gives you a very good idea of how EPID works. And then the seminal paper on it on enhanced privacy ID, right up in Dr. Dobbs that kind of explains it, and then a reference on the curves, the Pareto-Nerig curves. So with that, thanks for joining us today, and good luck to you in making the Internet of Things secure.